Hello, everyone. My name is Yonsli. I'm a professor of supply chain and logistics and maritime port management at New Jersey City University. I'm going to demonstrate how to use built-in Excel server to solve linear programming. I'm just assuming you know how to design the model, how to develop the model and then design on spreadsheet, but I'm going to demonstrate in my ways. To demonstrate the built-in solver, I'm going to use Ragsdale's 2017 edition of Spreadsheet Modeling and Decision Analysis, published by Cengage. So on page 49, there is an example of Blue Ridge Hot Tubs linear program. I'm going to use that example as to demonstrate built-in solver here. So you open the Excel and you study the Excel application from Microsoft Windows computer. And if you have Mac or Apple computer, you may have different ways to start the linear programming, but I'm going to use Microsoft here. Actually, the example has two different products. It's kind of a product mix problem. So two products, Aquaspas and the other product is Hydrolux. Okay, so let's adjust the size of the cells. And I'll say this is a decision variables. And say those are product type, right? So say, okay, cross bars. Actually, this is X1 and Armada, and Hydrolux is X2. We just need to have label of these two variables, and those we're gonna have number of product make. So this is X1 and have a different color, and say this is, let's have a placeholder for X1. If you, let's assume you produce one Aquaspas and one Hydrolux. These are the placeholders. So the application will find the solution of these two values. Then if we just need to assume all the products produced will be sold in the market. So once we produce one Aquaspa that will be sold in the market, the profit of product per unit is $350 for X1 and $300 for X2. So these are the dollar values without decimal values. Gonna put that in the middle to make it easy to read. So have decision variables, then we need to set up the formula of objective function. And subject function should be formula. So to have a formula in a cell, need to enter equal sign. Then D6. See, the object function and the mathematical programming was 350x1 plus 300x2. So $350 here times x1 plus $300 times x2. And this is object function. We're going to have a green. So that means if we produce one aquaspas and one hydroloxes, your total profit will be 650. This object function is subject to we have three constraints. So first constraint is about number of pumps. And the second constraint was labor hours. Third one is tubing. And then, okay, pumps, the unit of pumps. And then labor, number of hours, unit of labors, so hour. Just to the right hand side, then subject to. Okay. So if you read the textbook, it says one pumps will need to produce one aqua spa. So one pump for hydrolysis. And then also, let's see, 9 labor hours for aqua spas and 6 labor hours for hydrolysis. We need 12 feet of tubing for aqua spas and 16 feet of tubing for hydrolysis. Again, we're gonna just meter. And these are the primary data, 350, 300, and 1, 196, 12, 16, 350, and 300 are the coefficient of the object function, while these 6 values are the coefficient of constraints. So these are the primary data, and we're gonna leave them as it is, and to have a formula of constraints which are left-hand side. The formula was 1 x1 plus 1 x2 was the left-hand side of first constraint of pumps. So we want to copy this formula to the other 2 cells. So to copy that, these decision variables are fixed cells. So I'm going to highlight T6 and E6, then press F4 in Windows system. So you have a $sign, which will be absolute address. Then press enter, then copy this formula. And these are the left-hand side of constraints. So I'm going to have color of red. And as you remember, the pump should be less than or equal to 200, which is a limited resources. And number of labor hours will be less than or equal to 1,566 hours. The total number of tubing the company carries should be less than or equal to 2,880 feet. Oops. Okay, So this will be right-hand side. And these are the constants. So I'm going to have yellow. Now you see, we have two decision variables, x1 and x2. We just have a placeholder of 1 and 1. So we can just put it in 0. Then your total profit will be 0 because object function is a 350x1 plus 300x2. This object function is subject to the following three constraints, including number of pumps, number of labor hours, number of tubing feet. So 1x1 plus 1x2 should be less than or equal to 200 pumps. 9x1 plus 6x2 should be less than or equal to 1566, and 12x1 plus 16x2 should be less than or equal to 2850. Okay, so these signs are not necessary, but to have a better understanding, I just enter those signs in those three cells. Now, next step is to solve using built-in solver. If you haven't used the solver, you need to set up in the Excel menu. To set it up, go to File and click Option, and you'll find Add-ins. And on the bottom of the Add-ins, and you'll find button Go for Manage of Excel add-ins. Click Go, and you have add-ins pop-up window. And I don't think I have solver add-ins checked, so I'm gonna check it. Then click OK. Once you add it, and that should be available from the menu. So now click the Data tab. In the ribbon menu, you will find the icon of solver. So click the solver icon, and now you have a solver parameters. Pop-up window. So in the set objective input box, we need to select object function, which is the cell D9. So we're maximizing profit. So we just check radio button max. And by changing variable cells, we need two decision variables. So highlight D6 through E6. The next step is to add constraints. So to add constraints, click Add. And you can add constraint one by one, or you can add three of them at the same time, because three constraints have the same signs between left-hand side and right-hand side. So cell references will be left-hand side. So highlight the range of left-hand side, which will be F12 through F15, and should be less than or equal to. Constraint will have right-hand sides, which are in H12 through H15. Once you add them, you click OK. And the pop-up window, you see this subject to the constraints have three constraints for now. And then you have a checkbox, make a constraint variable non-negative. We have x1 and x2, which are not negative. So we need to check this box to make those two decision variables being non-negative. In the drop-down list box of selector solving method, we're gonna select simplex linear programming. Then need to click solve. The message says solver found the solution. All constraints and optimality conditions are satisfied. So we're going to keep solver solution because we found the solutions. And then click OK. Now on the worksheet, you see the value of x1 is 122, value of x2 is 78. That means if we produce 122 aqua spas and 78 hydroluxes, Blue Ridge hot tubs will generate profit by 66,100. Now you see the left-hand side, 200 for pumps, and it is consumed all pumps, while labor hours are also consumed. So that means Blue Ridge hot tubs hired employee, and all employees' labor hours are used to generate the profit of 66,100, while tubing has excess inventory. So the company carries 2,880 tubing, but only 2,712 feet of tubings are used to produce 122 aqua spas and 78 hydroluxes. Okay, so I just demonstrated how to use a built-in Excel solver to solve linear programming with Blue Ridge hot tubs example from spreadsheet modeling and decision analysis.